Welcome to Axon tutorial, and in this video we'll look at how to light the electron configuration of an atom. Okay, so let us see how we can light that, and please you can join us. So everything is there, the description, the number is there. You can join us by inboxing that. So let us see. At the end of this video, should you be able to identify right electron configuration of any element. All right. So first of all, what you need to know is that they are what we call SPD orbitals. Orbitals, we have about 4 of them. All right. There are 4 that will be using in this study session. So the first orbital, we write them like S, all right, P, all right, then D, then F. So these are the orbitals that we need to understand. So now I want to give you a trick, and that's why I said easy way of writing electron configuration. I don't want you to be using arrows, pointing arrows like that, the way I've been doing with a lot of people. Now that we have upgraded, we'll be using these now in a simple way. So one thing that you need to understand is list them again: S, P, D, F. Okay, list them like that. By the way, that must be, yeah, yeah, must be like that. Okay, so SPDF again. I want you to repeat SPDF. Just repeat, keep repeating. Then from there, I want you to write in this order. You can see that these guys now are in this order. We can count them to say, okay, we have S, P, D, F. I've just repeated. So I want to what's this? I want to number them. So I'll number them as this is number 1, number 2, number 3, number 4. They are listed like that. Now the next thing that we are going to do is we'll list them. We'll be using arrows like to your left. You move twice. So you move like that twice. Again you move from there twice. Again you move from D twice. Again you move from there twice. Is that okay? So what I'm trying to say is we'll move first as S. In fact, let me start from there so that we create more space. So I said we'll start from um S. Again, I'll start now from P. I'll move like that twice. So that will be PS, PS. You have seen? Again, I'll move at D twice. So coming to my left, so I'll say DPS, DPS. So this need to be in your head. DPS, DPS. This has to be in your head. DPS, DPS. Then we go now from here. FDPS, FDPS. So by writing this, you have a lot. I'm just like trying to show you how maximum you can maximize by ending at that, and you will be able to establish of any element. So now that's what we are saying. Now we'll say FDPS, again FDPS. You just repeat like that. Is that simple? So you say, okay, FDPS. Pardon my handwriting. Again FDPS. So now in front here, I'm going to put numbers. Okay, I'll count them. Like I'm going to count these numbers. I'm going to count them. All right. So I'm going to count these numbers. For example, here, this is the first S. Okay, this is the second S. Okay, this is the third S. This is the fourth S. This is the fifth S. Sixth S. Seventh S. Seventh S, then eighth S. I'm sorry for that. Then from there, the next thing that you're going to do is you can see P start at number 2. So you start from there, number 2, number 3, then number 4, then number 5, number 6 there. You look at it, then number 7 there. Then you can start at 3. D start at number 3. So whatever there's D, start at 3. So start 3 there, then 4 there, then 5 there, okay, then 6 there, okay. Then you can see F will start at number 4, so start from there, 4, right, again 5 there. Okay, so this is it. This is what we need to know. From there, if you are able to actually come up with this, is to know that how does these orbitals look like. So what we need to know is that let's say s orbital. I want to write s orbital look like this. It's just one box like that. Then coming to, so this is s orbital. So p orbital, it has 3 x, y, and z. So like in one degenerate, like they are of the same energy, but divided into 3 like that. So the maximum it can have, it is 6 electrons, because we'll be pairing in these boxes. Here it is 2 maximum. Here maximum is 6. Then coming to D now. D, it has 5 boxes. So 1, 2, 3, 4. So these are 5. So you can see that if they are paired fully, they will be 10. All right. So you end there. Then F looks like this. So F has 7, which means that if they are fully filled, it has to have 14. So we have 1, 2, 3, 4, 5, 6, 7. All right, there are 7 now. So what we are going to do is, this is how you'll be feeling if you're asked to say, can you write the electron configuration of this atom, write the electron configuration of this. So this is what we'll do. For example, zinc. Now you look at, we have seen now the maximum that we can have here is 2. The maximum we can have here again is 2. The maximum we can have there is 6. The maximum we can have there is 2. The maximum we can have there is 6. The maximum we can have there is 2. The maximum we can have there is 10. We have seen for d orbital there are 5, so we can have 10 electrons there. So the maximum we can have on p orbital is always 6, because you can see there are 3 boxes like I've been saying. Here again is 2, like we said for this orbital. Then this one again is this one is 10. Then this one is 6. Again 2. F is what? This is 14. This is the maximum. Unless if the electrons can't fall, like let's say it was the last orbit and you have just, let's say 10. You leave 10 there. But if possible, leave before you go to the next. Leave 14 of them. So 10 there. Then 6 there. We have also 2 there. Okay, then 14 there, then 10 there. I think these are a lot. We'll be ending somewhere. You can even write there. Okay, P again it has 6, then S again it has 2, like that. We all know this now. So this is what we need to know. Then from there, let me give an example of, let's say, an element. Let's say any element, let's say that has the proton number of, let's say 8. Okay, so for 8 proton number, you say for oxygen. Okay, so the electron configuration for oxygen will look like, so I'll get 2, 2, you say. So that will be 1 S2, then 2S, okay, then 2 there. I've used the 4 now, so meaning that here I was supposed to have 6, but I'll say 2p, okay, but how many 4 are remaining? So I'll put 4 them, because it can't, I wouldn't have moved to the next orbital when I can't fulfill I can't fill in this, what's this orbital, which has this 6. Now we only have 4. So this is the electron configuration for oxygen. Let's go for these guys like that they normally ask, like the zinc, copper, chromium, stuff like that. So then there will be what we call let me first give an example for zinc. Okay, so zinc, it has the proton number of 30. All right, so zinc has a proton number of 30. So what you do is, okay, since zinc has a proton number of 30, so what we are going to do is we start substituting and we'll count, even you'll see where it's ending there. So we have the first one is 1s with 2. The second one is 2s with 2. The third one is p with 6. Fully now we have, because we still have a lot. Okay, then we have 3s there with 2. Then we have 3p there with 6. Then we have 4s there with 2. So I want to explain something that you need to pay attention. Okay, after 3p, wait just a moment. We have here 3p, I mean 4s, 4s we are here, then we need to come on 3d after 4s. All right, so after 4s we come on 3d. This is where first, before I even move like this, I need to have a direction. So I count 1 2, that is now we're having now 10 10 11 12 12 18 18 19 20. You have seen. So I'll come now on 3d. So 3d now it has 3d has, remember I have now 20, right? I have 20, right? So that will be like this. So 3d, you put 10 there, because it's now maximizing the 20 loop. You have seen, it's now maximizing the 20 loop. So you end there, right? You end there. So if you want, there's also a shortcut for electron configuration, like whereby you substitute for the noble gases for 18th electron, but I won't do this in this video. We'll do it in class. So this is how you can write the electron configuration. But there's a case whereby at some point where there is s between s and d, and you find that here you have, let's say 2, it has fulfilled, where between the, where they will sit like F4SD like that. Let's say, let me in fact give a clear picture of what I'm trying to say about. Suppose some elements you have obtained, kuma last go queen, you have obtained, let's say 4s. Okay, 4s is having 2, then 3d is having what, is having, let's say 9. Okay, these are what you call exception cases. Okay, and again a situation whereby 4s it has been fulfilled with the 2, then 3d it has, let's say 4. You have seen. So this has to be exempted. Like this is how you, these they'll undergo what you call excited state, whereby this electron will jump to that, one electron will be shared, so that you remember d orbitals can only have like 1 2 3 4 5. All right, so they can only have 5, or they can be 10. This is how they need to be, because you need to make sure that if possible, make sure that them 1 1, you don't leave any orbital like blankly. Okay, because there's a lot of works this expulsion here. So you do that. So you excite one electron from 1s, and that will be 4s with 1 electron. Then there'll be 3d now with 10 electrons. This is how you excite, and the case of copper applies. So again here we are going to say, okay, that will be again 4s with 1 electron. Then on 3d they were supposed to be 4, because we let us now, like these degenerate orbital, we pair them 1 1. So that will give us, d. All right, now d5, because it was d4, 1 electron has been excited, and that's what we call excited state configuration. All right, so let us see this example. And for the zinc we have given, I got just this copper, and we'll draw the orbital diagram if at all time will allow. All right, so light, they are saying copper is 29th. So you have seen this is the case. The other metal that I was writing is for, what's this, for zinc, is for zinc. So this means that there are 2 guys, chromium. In fact, okay, can you do this, but I'll give for chromium. Chromium has also the same exception case. So what I'm going to do is, I won't answer this, I want you to answer, but I'll answer the same element, which is chromium. Let me write chromium. So chromium has the 24, and it has the same type of behavior. Okay, so now what will happen is, like we start, okay, in the head we need to say we have ss, ps, ps, okay, dps, dps. That need to be in our head the way I've listed it. So for me, I'll go direct now. Having that, we have understood that. So s2, again s2, we know they have listed now 4 of them. Again, I'll go on p, which is start at 2, so 2 p6. All right, so that is 6. So far I've used, then we have 3s, again ps, ps. Okay, then again p, which is 3p. So there we have 2, there we have 6. That's the maximum. I'm targeting the 24, by the way, in my head, so you need to know where you are ending also. Then you just list the whole configuration, then you start substituting like this. That's the only way I can advise you to be doing it. Then we have we have what we call now we have what we call now 3D. 3D has, it is now having, by the way, I don't have to write this like this, but instead I'll write it. I was supposed to, it's supposed to be PS, right? So I'm writing PS there. So that is S again. So that will be 4S. You remember the format has to be in your head. So I have 24 of them here. I've listed already 4, 10, 12, 12, 18. 18, right? 18, 19, 20 there. Okay. So I'll put 2 there. Then there will be now the D part. This is where you need to actually now like summarize. Now we have 3D. Okay. The fight is always between S and D. So pay attention on that. So it has 4 there. So this is where I said you can't leave these guys to be 4. At least if they were 9, try by your best to borrow one from this S and give it there. All right. So always be writing like this configuration, please. Then this means that the final configuration that you are going to write is, I'm just substituting on the case of S. So that will be S, one electron will be given to 3D, and that will be 3D5. The rest, these ones you can copy like that. I don't want just to list them. So now that we have understood this like you bring these 1S to 2S to 2P 6, 3S to 3P 6, then the rest is that. This is how you need to write the electron configuration. It's very simple, yes, but they will give you now, this is what we call excited state, this is what we call ground state. So this is what will happen also for the copper. Give the ground state configuration, this is what you do. All right, this is what you do, this is what you do. And the excited state is this one, like whereby the one electron has been excited to onto the d orbital. That is what we call excited state. Let me help you on how to write the electron configuration, I mean the orbital diagrams, like the question demands. So if you are to write orbital diagram, first you list the energies. First energy, second energy, third energy, fourth energy, if at all. These are like, I think I'll end there. So what you do is, I think I won't reach 5. Oh, I can reach 5. Let me reach 5. So what you do is, these are the energy levels. So the first orbital, like for example, we want to write the orbital diagram for this element. We have S there. So in the first S, we write like that, okay? Because it's 1, okay? It's 1 like that. Then 2, we have again 2S like that. They need to be close to the numbers, these the S's. Then the P, I mean, we just like on number 2, all right? I'm just listing the S's that will be found here, all right? Like the S orbitals that will be close to, because we start with S, P, D like that. So in the same energy. So the first I'll list is, okay, this is the S orbital, okay? I'm just listing it because these are the orbitals we have, okay? So remember I said we have S, P, D, F, okay? So with these numbers now, I've listed the first orbital, then the P orbitals for all. You have, okay, for example, the same one we have the S, then S, okay? So this means that at 2S we have this S and S. So then there's also 2P, okay? So we start from here as P. So we list all the orbital for P, the way it looks. It looks like this, okay? Is that okay? Then again, you look at what you have there. Okay, P, S, again 3S. At 3S, again, I'm putting another S there. So I've already I've put S there. And again, for P, I have also again done that. So we'll move like that. Then again, we'll move like that. This is how just they are arranged. Okay. Then you start again where this guy joined from, the D. Start at 3. Okay. So you start from there. This will be for the D. You list 1, 2, 3, 4. I think this I have to do it in an exam. But the other way you can write it, So you continue writing that, and also that one you will continue like that. So you'll be writing these orbitals like this. Or the other way you can write these orbitals, you write the way they are there like that, but they need to be differentiated in the energy level. That's why I decided to write this. Okay. So I decided to write this. So for example, this one, it has at 1s we have two electron, you have them like that. Then at 2 we have 2s, I mean we have two of them, like 2s. So you say 1 2, you have paired them like that. Then again at 2p, so 2p here it has 6, so you pair them like that, like that. They need to be paired, they are 6. I'm just writing this for for demonstration sake. Then we go to 3s. 3s again we have 2, so we list them like that. Then there's 3p there, 3p6, so it's fully filled also. By the way, these are the p's. So also 3p, it's also filled, like you pair them like that. Okay. Then we go to, this is where we end, I think. Then okay, we go to 4s. 4s again, we light two just electron like that. Then 3d. 3d, it's now here, you have seen the d part now is here. So the 3d here, all right, is it has 5 of them. So now this is 5. By the way, there is also in 4s, there is one electron just there that will jump to that guy where we said that the 5 will go there. Then like that, I'm following this. So this one electron which was there, which came from 4s, I'm not writing it here. In fact, this is just one electron. This is excited state. If it was ground state, you would have put 4, then this would have been 2 electrons. So again, you continue, like this is the end, but you would have listed also all the d orbital, like that, for just demonstration sake. Then you write now, then the f orbital, you also write them, like you start from here, you go like that, the way I was writing like that. So this actually marks, or you can write in a straight way. I've been seeing like some lecturers writing in a straight way. So what you do for the straight path, you just list the way they are, like the s orbital you have 2, then the second orbital will have, you just write these numbers like that. Then you write the number of electrons there. Then we have again 2p, you just write like that. You write the 6 of them like that. You write like that. Then you have also 3p, I mean 3s, you write just one orbital. Then again we have 3p, we write the p orbital like that. Then you list those electrons. That's actually the smart way also, but I like this one because it shows the knowledge that you can have over this. Than this, they like using this, so you can adapt any of the two. Actually, this has to give you everything about. So try this. You can capture this and do that. Draw the electron configuration and also the bit diagram for this. So this marks the end. Thank you very much. You can join us and see how we can progress together.